Aqui não apanhas no pé. Estás sentado.
Hello. Just out of curiosity, does anybody has a Thunderbolt to VGA adapter? We're missing one. Okay, thanks. I think we can carry on. Vasco comes from Mindera, a startup in Porto. that I also work on. He's gonna talk with us about microservices and some cool stuff. Good luck.
Hello? Yes. Está a fazer feedback. Eu não dou bem com isso. So, as Pedro said, I'm Vasco. I'm a developer at mine there. There's nothing much. Vou usar esse mesmo. Estou? Ouve-se? Consegue-me ouvir? Suponho que sim, né? So, as I was saying, I'm Vasco. I'm a developer at Mindera. At the moment, I'm there developing microservices for almost a year now. And I was asked to come and talk about microservices, and I'm talking about microservices. As you can see, I clearly know what I was going to present myself, because the title says it all, right? So basically, this will be an introduction to what microservices are, what's the comparison between microservices and monoliths, and what's so big about microservices, what are the challenges when you move from a monolith to a microservice, okay? So let's start off with an example. Let's say I'm building an app similar to what eDreams or Flight Scanner does, okay? So I want to have alerts, I want to be able to check in, purchase tickets as well, making comparisons between flights, and I also have a trip management feature, okay? So I basically start out with gathering the requirements, all that project management stuff that we all love, and I build a nice service layer, a domain layer inside my monolith. I start making a service layer which has all the business logic, right? I have domains in there. I integrate with third parties as well. Then I build the interaction with the outside world, right? So I have database components, I have messaging components, we integrate with third parties. I even have a web component to expose an API so future clients can integrate with it. And it's a fairly simple application at the moment, right? So a monolith will do exactly what I need. So a single web application. Can be MVC, can just be a RESTful application with a client on the other side. Is this doing too much feedback or, yeah, a little bit? Let me try the microphone. Hello. If you have any questions, just shout or raise your hand. Okay, it's fine. And if you're not able to hear me or you just don't care, do say something. So where was I? So you basically built this basic web application. You can do it with Spring Boot, Rails, Node.js, even though I wouldn't recommend it, but you can do it in all sorts of things, right? And it starts at small. You start adding components, not a big deal out of it. You get all of these nice properties with Monolith, okay? So you shouldn't actually move into a microservice architecture right from the beginning. You should start out with a monolith. It has a fairly lot of advantages, so it's simply to build, it's simply to start. The database replication, for instance, won't be an issue. You get AXI transactions. You can do end-to-end testing. You just have to mount your application and start testing, right? I just have one component to deploy. That's basically it. I've gone too far. Let me see if I haven't forgot anything. Oh, yeah. So these advantages about the monolith, okay? As it grows over time, I'm starting to add more and more features. As a product owner or as a company, I want to engage the user more and more. And as this starts to grow, it starts to be unmaintainable. That's the problem with a monolith. All of a sudden, you have over 1 million lines of code, for instance. No developer that comes into the team can catch up quickly with a project. What's all the business logic? It's all this entangled code. As business wants faster and faster fixes or features, what happens is you start getting spaghetti code, right? I think we all know this term. The framework that you started out with At the time seemed a nice, it looked like a nice framework, but as time progresses, new frameworks come into mind, and it's hard to move the monolith out of that framework. So changing to a new framework will either require you make backwards compatibility with the old framework while maintaining a new framework as well. It gets a little tangled up as well. Or you just waste the time making your entire application from scratch with a new framework. If you don't change from frameworks as well, what happens is that it's harder and harder to get developers to work for your product as well, right? I mean, who wants to do Visual Basic at the moment? By the way, eBay, Amazon, Netflix, they all started out with a monolith, okay? And they progressed to a microservice architecture after they had a monolith and started having some issues. So moving to a microservice application. It's fairly easy if I have my code separated. So previously I had these all nice new modules, but I don't have a hard layer separating this business logic, right? All I have is functions and functions, objects, depends on your language, but you just get like packages or namespaces or even directories if you're working with Ruby or Node.js. And when I move on to microservices, I get a whole different perspective. So I start having a REST API or whatever communication goes in between. I'll go into further detail in a little bit. And I get this hard separation between the concepts that each microservice does, okay? So what exactly is a microservice? Microservice is nothing more than a single bounded context, single piece of functionality that you can isolate inside your code and extract it to a simple application, okay? So it's kind of how we started with a monolith, except we have some more features. With the microservice, I just want to go with simple modules that separate me with a hard line between each service, right? Okay, so this is just an example. I have the 4 features that I had planned out previously, each on its own microservices. They talked among each other as they did previously, except previously it was just a function call or a method call. Now I have to REST API call or whatever protocol I'm using. And I have an API gateway, which I'll talk in a little bit. So scalability with microservices. Scalability comes in 3-dimensional space. So 1-dimensional is what I have with a monolith. I just do a horizontal replication, right? So I have a single WAR file. How many of you work in Java, by the way, or Node.js? Let's see, more or less. Java. Who works with Java? Okay, more or less 1/3 of the room. Node.js, less people. Ruby, backend, anyone? Yeah, okay. So if I have a single service layer and that's all I interact with, I can do horizontal scaling, right? I can just start deploying my web app as I have my web application. So if I do it in Java and I have a WAR file or a jar file with Spring Boot, all I have to do is create a new server, run the service, and that's about it. I get multiple applications. Put it behind the load balancer. That's it. It's done. There's a database behind it. Not much less. Tá melhor assim? So 2-dimensionality. Dimensionality, the second dimension comes up with the module decomposition. So when I start decomposing my monolith into several modules, I can start scaling out without the need to scale everything. So if you look previously, let me go back to my monolith. If I want to horizontal scale this, it doesn't mean, let's say that the alerts is the critical part. So at the moment, I'm sending out lots and lots of alerts, and the server just can't keep up with it. If I want to replicate this, I have to replicate the same thing for alerts. I will have to replicate for checking, for purchase and trip management, right? But if I have a microservice, I can just bump up the alert service without replicating anything else. I also can adapt the scalability to my needs. So let's say that alerts is a high computational component of is a highly computational service. It requires lots and lots of processor. It does quite a little bit of computing. But the check-in, for instance, uses lots of memory. I can adapt that, and I can deploy the check-in service, for instance, in a machine that has lots and lots of memory. I can deploy the alerts in a machine that has lots of computational power, right? So second dimensionally. The third dimensionality comes by partitioning data. This doesn't mean partitioning the database, so dividing the database for each microservice. What this exactly means is every time that a request hits the servers that I have, I can make the request go to the same server, right? And I can do this with geolocality, for instance, based on where the request is coming from. So let's say I'm making a request from Portugal. I can hit a data center that I have in Portugal. Let's go for the States, for instance. We have West Coast and East Coast and even Central. We have 3 data centers there where you can deploy, make requests go to where the person is most nearby, more proximate to, right? So these are the 3 dimensionalities that I can do scalability at the moment. Also, when I move to Microservice Approach, one thing I have to consider is that the database will get divided. So each microservice should have its own data, right? That's the whole reason why I divided my services in the first place. I wanted to have a single piece of functionality for alerts and trip management, and the trip management service is responsible for managing its own data. It should be. When I have a single database for all of these microservices, if it's an SQL instance, for instance, and I start doing transactions with the database, the requests start piling up. Because I'm doing transactions, I'm not committing transactions up until the end, and the database won't just make any other transactions while an undergoing transaction is ongoing, right? Basically, yeah. Oh, also, this allows me to divide and conquer, right? I can make several transactions in several pieces of data without impacting each other. One of the things that I get as a bonus on this side is I get loose coupling between services, which is a good thing. I don't want the services to be hard coupled between each other, okay? I want them to be as loose coupled as possible. This will allow me to evolve. This will allow me to evolve the API without breaking other services. One of the nice things I get with microservices as well is that I don't have the need to be afraid of deploying my web application again. As well with the Monolith, every time that I make a new feature, I'm deploying the whole web application from scratch, right? With the service, I'm just deploying that bit of functionality. If it breaks, it's contained inside that. Sure, some clients might break because of that. Depends on how you deploy services. But since it's loose coupling, and if the service doesn't actually depend, I'll be only impacting a subset of the system. This also gives us a lot more freedom for us developers, okay? One question that should be asked a lot when you start out with microservices is how small should a microservice be, okay? What's a good unit of measure? Is it like 100 lines of code, a small enough of microservices? If I get to 500 lines of code, should I start breaking it up again? A good rule of thumb is usually you should be able to recreate a microservice in under 2 weeks, more or less. Okay? It's one of the good things about microservices. We as developers can take risks. If at the moment Kotlin is on the hype and I want to try out Kotlin, there should be nothing separating me from trying out the service in Kotlin. The only thing that the only thing that should prevent me from doing something in a new language or a new framework with microservices is what else should I integrate with. So let's imagine that I have metrics at the moment, and I have a server that collects all these metrics and makes graphs out of it. We'll come to it in a little bit. You'll have the trouble of making the libraries necessary for that language, okay? If I have an architecture that's primarily Java-based or JavaScript-based, I'll do all of these sorts of libraries to avoid doing work the next time that I have to build up a microservice, right? And if I start doing things in a new language, what happens is I'll have the trouble of making those libraries again for that specific language. Okay. Oh, it's harder to test, by the way, because it's not as easy to stand up the whole system as it was previously with a Monolith. And a Monolith has to start the application, that's it. With a microservice, I have to stand up all of those services to get the whole system up, right? On the other hand, UI, user interface developers, JavaScript developers, front-end developers, mobile developers, it's a lot more easier to do A/B testing, right? Where you can test out 2 different scenarios, and I can just stand up 2 different services to accomplish that, okay? Yeah, that's about it. Oh, just curiosity. Netflix at the moment has like 600 microservices. Uber has gone from over 1,000 microservices as well. So it's also possible to screw up the system. Not in such a way that the system will start misbehaving, but I can have replicated microservices. Okay? I don't need to coordinate between developers as much. And what happens is if I don't see a functionality right in there, I can just create it, and I might get duplicated microservices or services. Okay, API gateways. So let's imagine that I'm starting to build my mobile client with all of these microservices, okay? It's not a good thing for the client to make all of these sorts of requests to get the data. Let's imagine that my mobile application needs like product details, and along with the product details, I need also customer review, what else? Shipping options, if there's an inventory or not for that specific item. So this can be contained in different microservices, right? And I don't want to start to my client to just load a page to make 7 or more requests, 10, 20 requests to the microservices, each on its own location, by the way. So I would have to know every single location of the services to make all of these requests. It will make the client code much harder to perform. I would have to fetch data from all those stuff. I would have to aggregate the data. This is where an API gateway comes in handy. What I have in front of microservices is a gateway that provides functionality for the client. Basically, it calls a bunch of services, aggregates all of that data, and returns back to the client. It's kind of like Node.js for front-end developers, where you have difficulties making several connections. The browser won't allow you to make more than a certain number of connections. You can use Node.js to allow that, to bypass that limitation. That's basically it. And since it's in the same language as you develop in front end, you can easily do it, right? I also get the new concept with the API gateway becomes an edge node, so something that's at the edge of my system and that everyone will interact with, okay? I can have different API gateways for every client, so I can have a gateway for mobile clients, I can have a gateway for front-end development, for browser development. I can even have gateways depending on the devices that are consuming my services. For instance, Netflix has to support a lot of set-top boxes, TVs, gaming devices, right? I get Netflix, either it's on Xbox, either it's on Mailbox or Vodafone box or whatever it is, a smart TV from LG, whatever. I can have different gateways for that. Netflix actually started having one single gateway for all of these services. Then they quickly realized that they were trying to generalize something without, and they weren't meeting to the client's needs. The clients meaning all these devices that are interacting with the service. Yeah, that's basically it. So communication between services. How do we communicate between services inside our layer? Okay, we have a lot of choices. Microservices is all about trade-offs. So when you were in Monolith, you didn't actually make these choices because they were quite clear what they were. So why should I go with multiple databases when a single database will give me access properties? Why should I start making outward HTTP requests when I'm in a single server, right? When I moved to microservices, I got all these trade-offs, and I need to decide what do I want and what do I don't want, okay? So going back a little while, by the way, when I have all of these microservices, if I'm on the cloud, for instance, having microservices more fine-grained, so more specific microservices, I'll also drive up the costs of the company because I'll have more containers, more machines running, right? And that will impact the business as well. This can be, usually it's not relevant for us developers, but for the business usually is, and it drives some of the decisions as well. And when I get to communication between services, I get all of these kinds of communications that I can have. So I can have either one-to-one communication or one-to-many as well, and I can also get synchronous and asynchronous communication. So for instance, if I'm using a request response communication, I'm doing a one-to-one and synchronous, because when I perform a request, I'm waiting for a response back, right? Notification, it's asynchronous. I just do something with it, notify that service that something happened. I don't have to wait for a response. This could be like UDP. Instead of TCP, I don't have to create a connection, just fire and forget. What else? request async responses. So I make a request, then asynchronously wait for a response. I don't necessarily need to wait for one. I can pull the data until it happens, or I can just wait for something to notify me that, hey, this event just happened, do your thing, basically. Okay, this is a one-to-one as well. Publish subscribe model is also a very familiar model. It's a messaging model, like RabbitMQ. I just publish to a message broker one message or one event, and I can have all of these clients subscribing to that event. I don't even have to know which, which clients are picking up that event or that data and doing something with it. I just send out a message, and if anyone's listening, they'll do their thing, right? Publish, there's a typo there. Publish asynchronous response. It's the same thing as the previous one, except with a request, I don't have to wait for it. I just publish it and wait for asynchronous and coming. So this is usually a microservice system, by the way. A whole system can have all of these protocols at once. It depends from microservice to microservice what their inter-process communication is. So, for instance, I get a client that just sends out a notification to this service makes a request and waits for a response from this service. Doesn't really know what he's doing. I mean, let's say he's just asking for customer data from a customer microservices and waits for that data. And once he gets the data, he can continue his work. He publishes to a message broker whatever just happened, and two services consume that data, right? I can have all of these things inside my network. I think I'm missing something. Oh, yeah, if I'm doing request response, usually I do it with HTTP, like REST, for instance. And the others is like messaging, RabbitMQ, ASMQ, Kafka streams, whatnot. Another thing that I need to be aware of is when I divide my monolith into several services, one thing that's ever present is the system will fail, whether you like it or not, okay? So hardware fails, it's not of your code, hardware just fails. Clouds get outage sometimes, they just go down. On a monolith, I either get a full application or I don't. And I need to find a way to handle with all of these things, okay? Netflix deals quite good with these kinds of errors. They even have something around their development environment or their cloud. They have like a bot that goes into a service and just kills the service entirely. And the system still goes on without anything changing, basically. The system will adapt itself to it, okay? One thing, good approaches for this, for instance, is never wait for a client for a response, okay? Implement timeouts. Wait for a certain amount of period, then just timeout. Doesn't really matter if it will respond back in the future or not. I can't wait, I shouldn't hold up resources waiting for a response for a client, okay? The response might never come back, okay? Limit the number of requests that you're doing, okay? Do this by creating a pool of connections with a given service, and if you reach up the maximum number of pooling, just don't make a connection to it, okay? The service is basically at its top, and this means that you're not probably doing load balances well and you're getting hotspots, or you need to scale out your application more, basically. Also, any of you know the circuit breaker pattern, for instance? No? Yeah? That guy over there knows. So the circuit breaker pattern is one of the patterns that's described by Martin Fowler. And what it basically does is it keeps the circuit, I don't know if it's open or closed, keeps the circuit closed, I think, and it just lets requests come out of it. So to other third parties, let's say I had here a request response, right? It just keeps making those requests. And if I pass a certain amount of threshold, let's say that 5 requests in a row failed, I'll just open the circuit and return something default. A cached value, for instance, something say that the system is down, I'll just throw an error. But basically what I won't be doing is I won't be sending more requests to that service for a certain period, okay? This can be time-wise, so for 5 seconds I won't send out any requests to this service again. After 1,000 requests I will start sending them. It's configurable, basically. That's basically it. Okay, request response. A good way to make request response is by using REST. there are several levels of REST that you can implement. Usually, no one does full RESTful services. Does anyone know what's HateOIS? This dreadful stuff? Yeah? One guy? That's basically it. Okay, so REST allows me for request responses to, it's basically HTTP. I'm using 4 verbs of HTTP to communicate with a single service: get, post, put, and delete, yeah? To make RED operations with a given resource. And the good thing about REST is that the service is supposed to be stateless, so it doesn't have a state associated with it. This allows me to scale the application without ever having to concern whether the state is shared or not, okay? That's a database problem at the moment. HTTP is simple and familiar, by the way, so anyone that starts using REST and knows a little bit about HTTP, it's no big deal. And it's basically all I wanted to say. Another thing, publish and subscribe. Publish and subscribe allows me to place several requests. It allows me to talk from one place to many locations without knowing all of them, okay? It decouples a lot the client from the service. So the client and the service, yeah, so the client can also be a service, don't even know about each other. They don't even know they exist, right? I'm publishing a message to a message broker, and whatever is consuming, I don't even need to know where they consume, when they are consuming that data, what are they doing with the data. They just consume it, basically, okay? This gives me a lot of loose coupling, which means that if the service breaks, for instance, let's say that this service, I make a new version of it, and I make a new feature on it, I deploy that service, and this service just doesn't work. I'm not affecting the entire system. In fact, the clients that are publishing that information don't even know that service existed in the first place, right? I can also buffer messages, by the way, so as with request response, I need to hold on to resources and wait for a response to come back, and the service will have to answer me in a given time, otherwise I will time out. On publish subscribe model, I don't even have to do that. If the service is down, the message broker can just start storing messages, and whenever the service comes up, here, take whatever you missed the last time you were down, for instance, right? This allows me to buffer messages. I don't need to have the service up to do things on my system. A downside to this is that I'm adding an extra layer to my service, so more complexity to the system. HTTP is quite simple. There are lots of clients do HTTP. Message brokers, it's another layer of complexity that I have to be aware of. Also, this needs to be as well as with the API gateway. I didn't mention that earlier, but it's a highly available system. So I need to make sure that the message broker doesn't go down. If the message broker fails for whatever reason and it's not replicated, so it doesn't have the redundancy, I'm losing messages. These messages can be problematic or not, right? I can have weak data or strong data. Let's say that this is regarding a transaction on placing funds in a given account, right? It's not acceptable that this goes down and just lose funds. On the other hand, if it's, I don't know, just reviews and stuff like that, who cares if I lost a review from a customer? Service discovery. Okay, so let's imagine that I'm doing a request response type, right? I have my client, let's say that it's a browser application, a browser website, and I'm making all of these requests through my TVG, to my API gateway. And the API gateway needs to know where all these services are. You can see there, I don't know if you see it, but I placed some IPs in here. These IPs usually are random when I deploy them into the cloud or even on nearby VMs, on local VMs, on my infrastructure. Probably they'll get assigned a random IP and a random port. So how do I know which instances to talk to, okay? So there's this concept about service discovery, okay, that allows me to solve this problem, okay? Basically, we have two types of service discovery. We have client-side service discovery and we have server-side service discovery, yeah. So the client side is really easy. need to have a service registry, so another component that needs to be available as well in the system. Otherwise, I won't be able to communicate with any of these services, okay? And when a service comes up, it just talks to that service registry. It says, hey man, I'm alive, this is my IP, and I'm this service, so I have an identifier. Because don't forget, these services can be replicated horizontally. And whenever the client needs to talk to a specific service, let's say the API gateway needs to talk to this specific service, what it does is queries the service registry for where is this given service, and it returns back the host, the port, base path, whatever it needs, and based on that he knows which IP to hit, okay? It's relatively straightforward, there's nothing to it. One of the downsides is that my client needs to be aware that there's a service registry, okay? My client is the responsible for doing this logic. And I need to have this code in all of the clients that are going to talk with another service. Server-side service discovery. So instead of the client knowing where they're going to talk, they'll always end up talking with a load balancer, okay? And the load balancer is the one that's going to query the service registry. This can be, for instance, the main entry point for my system, like an external load balancer that I do previously geolocation based to send out to a nearby region of that client. And I query the service registry, I know where it is, and I forward the request to that. With this implementation, the client doesn't need to know where the service is, doesn't need to know that the service is using service discovery, so it always talks to the same thing. Let's say I'm doing a website at google.com, I can have the load balancer at google.com, no one really return back the website, but when the website makes AJAX requests to that endpoint, it knows what service to query, based on the path, for instance, and direct to the service, okay? However, the services do need to know still to register with the service registry. This isn't a bad thing or a bad thing. For instance, I give you a client side and I'm giving one of the server sides, okay? It's not one is better than the other. Like I said, when you go to microservices, you get a lot of choices to make. This is your choice to make, basically, okay? How do you want the service discovery to function? How do you want to discover new available services? Server-side discovery can be done, as I said. So a service comes up, registers with the service registry. The service registry is always at a known location. And from time to time, I'll just send, I'm alive, I'm alive, I'm alive, I'm alive. And if it times out, the service registry will just delete this service. Or before I go out, I just can unregister myself, okay? I can do this, yeah. Another thing that I can do on the server-side discovery is I don't need my service to register with the service registry, okay? I can have a registrar, so it's basically the entity responsible for knowing what services exist. They do health check, for instance. They check for the health of the service, and if they're up, I'll register the service for them, and I'll keep them alive as long as the health check comes back up, okay? So health, in case you're not familiar, is something that says if your application is alive or not and ready to reply to requests. If it's not, I can just restart it, send out notifications, whatever the case may be. Okay, that's basically it. I think I'm missing something. Oh yeah. Kubernetes, I don't know if anyone works with Docker and Kubernetes. Docker is this thing that makes containers, basically a sandbox for applications. Kubernetes is the thing that manages your containers, so allows them to get up, to restart them, to know how many are alive. Kubernetes has its own service discovery. Basically, every container that's in the Kubernetes system, so every container that you have in the cloud using containers, it passes to a proxy on Kubernetes, and Kubernetes automatically registers them on a service discovery. Okay? That's it. Okay, data problems. Yeah, in here I don't have any slide whatsoever, so I'll just talk a little bit about it. When it comes to data, you can choose whatever data suits your needs, okay? So if my microservice does nothing relevant and I want to use NoSQL because I think it suits my data, it doesn't need to have the consistency, it needs to have the availability, I can just make my microservice use that NoSQL storage, okay? If I want to have consistency, but less availability, I'll go with an SQL. If I don't even need any of those, and I just need some data that's volatile and will stop existing in the nearby future, I can go with a key value store, right? Something like Data Store or Bigtable from Google. The only problem that really rises here is when you want to scale out your application, if your database. So if you don't, let's say that you have 5 microservices of an instance A, right? Say the same 5 microservices that are scaled out horizontally, and you still have one database. If you want to have 2 databases supporting those, you'll need to have data replication. That's a topic on its own that would take complete talk, so I just choose to bypass it. On a quick note, Gemfire from Spring does a really nice job with these kinds of things. What Gemfire is an in-memory database with replication between the nodes that do the exact same thing. So let's say I have 5 microservices, I'll have 5 in-memory databases, 1 for each microservice, and they'll replicate data between themselves. Okay? They can even do this between regions. So let's say I have 2 completely different regions with 2 availability zones. Those regions will share the same data. Okay? And whatnot. So just some things to keep in mind when you're going for microservices. Try to find out some sort of configuration management, so a way to change configuration during runtime without having to redeploy your applications. Okay? This isn't really a must-have, but it will ease a lot of your development and a lot of your maintenance of your application. Right? There's a problem in production. You need to replicate it. You need, for instance, some debug information. You can just update the logging for debug level for that specific amount of time. Okay? You can also change, let's say a host changed its IP and didn't warn you. You can go to the configuration, change the IP, and the configuration server will automatically reload your application context with those new properties, okay? Without sending down the application, without having downtime. Spring Boot has a configuration server, and it uses Git to store configuration files. Whenever there's a change, it just pushes to configuration. So the configuration server lives in Git, which lives in the server, and the server will just call an endpoint for each microservice saying, refresh your application context, here's the new configuration. Okay? Other things that you need to be aware of is all of these things, so code, libraries, templates, and logging. Do be sure to create a library for everything, and I mean almost everything. Unless it's specific to that microservice, create a library for it. If it comes to the point where you need something and it's not just related to your service, it's kind of more a general thing, probably other services will also need that library as well to do something specific. The worst thing you can do is to have the same functionality replicated in 2 services with 2 different code bases. Okay? If there's a bug in one, you want to be able to update your library and do an update of your services on that library. Okay? It's self-contained. Templates. Be sure to create some sort of templates. Maven, for instance, has the archetypes, which allow to create quickly create a skeleton of a service, of a client, of a library they use. So instead of copying one service to another and deleting all of the trash that's related to that service and starting over, create templates for that. Okay? Logging. On the Monolith, you get this nice output on a single file, and you go there and you see the whole application just debugging to the same file. Microservice is completely different, right? We have several machines, each one logging to its own location, and if I scale this horizontally, I don't even know where the request will hit. So find a way to aggregate all of this logging data into a single file or a single tool, okay? There's Graylog, there's Sumo Logic. If you're on Google Cloud or AWS, you also have the Logwatch and whatever Google's log is called. And yeah, I think it's that. Monitoring. In case you've never seen these images, this is from a product of mine there called Statful, okay? On a highly distributed system, you want to be able to know how your system is behaving itself, okay? You will also want to have this with a monolith, don't get me wrong, but when you get to a distributed service, you want to know how many requests am I hitting on that instance. Do I need to scale out that particular module? The metrics will give you that, okay? Look for a way to take metrics out of your application and see how it's behaving, how it's responding to your requests, basically, okay? How many errors is it throwing out? Is it throwing out too many errors? Is the health down? Why is it down, okay? find a way to find this out without having the need to go into your IDE and just hit debug, replicate the request, and see where the bug is, okay? Find a way to see this and tell if it's a problem on that microservice or a dependency, something like that, okay? Oh, last but not least, find a way to document your APIs. Either if they're REST, for instance, use Swagger or RAML. So this is Swagger. In case you haven't heard, it's this nice thing where you can do a YAML file or a JSON file describing your entire API, and it gives you a fairly decent output of what resources do you have, what operations do you support. RAML does the same thing. I don't think it exists one for messaging, by the way. This is just for REST. For SOAP, you have the WSDL, right, which allows you to just query all of the information that service makes available. And yeah, that was it. Any questions? Otherwise, thanks for that.
É melhor usar os outros. Onde é que está o outro?
Som? Conseguem ouvir assim só?
Okay. A minha pergunta tem mais a ver com como é que nós garantimos a escalabilidade de um Service Registry e como é que nós conseguimos fazer com que o processo seja praticamente automático. É que não tenhamos que fazer configuração, redeployment. Como é que podemos tratar esses aspectos? Da parte do servidor, especificamente. Sim. Como por exemplo, isso parece-me ser um ponto muito fácil para eu fazer DDoS e rebentar. É um ponto de falha no sistema. Parece ser relativamente fácil estourar o sistema a partir daí.
Este não é necessariamente um web application ou pode simplesmente ser a minha API, o meu gateway. Portanto, quando tenho que publicar fazer DevFest, ou aquilo que depois explorar a internet, estás a ver, publicamente, é este gateway, um pouco mais que isso. É aquilo que deves pôr. Mas aquilo que não devias pôr todos os microservices, dá a fazer vários pedidos em cada microservice, para isso. Eu posso ver o vosso gateway, se houver um ataque de DevFest, antes de bater neste gateway, também deve bater no load balance. No load balance, elas firewall devem implementar prevenir mais DevFest. Aqui dentro, eu não tenho muito interesse em fazer ataque de DevFest. Pode acontecer, estou constantemente registrado e não tenho uma própria volta de todos os registrados, certo? Pode acontecer uma aldeia desse género, mas também devo evitar não estar a fazer pedidos, sei lá, 1 milhão de pedidos por segundo para mostrar que está no service registry, ou aquelas coisas. Em termos de aplicação de service registry, não há problema nenhum de criar um rollout. Isto é uma base de dados extremamente simples, tipo quase como se fosse um DNS. A aplicação de DNS é uma cena extremamente simples. Os dados não precisam ser consistentes, eu consigo fazer override de uns e de outros. A consolidação de dados também é extremamente simples. Portanto, eu simplesmente escolar isto e, por exemplo, não me passou muito bom.
depois do... Okay. So we're going forward now with André and José from Jumia. They're going to talk about progressive web apps and one thing called AMP, which is accelerated mobile pages. Am I right? Something like that. So they're going to talk about how you do apps in a way that you don't have always the loading and have to wait all the time for them.
Depois no bolso ou qualquer coisa assim. Ok. Já está, obrigado. Teste. So, hello everyone. We will talk in English. I'm not sure if there is still anyone in the room that doesn't speak, so to be sure, we'll speak in English. So, I'm André Maia. I'm a product owner at Porto Tech Center. He's José Santos. He is a tech leader, and today we're going to talk about... What, sorry?
You got my name right, yeah.
So it was good. So this is my first time speaking in front of so many people, so, please be gentle with me. Basically, I'm going to tell you a story about the way we work, how we work, and because we build things for Africa. For that, we use Google tools to try to make things better, faster, stronger. Okay, so let's start. So, we work for Jumia Travel. We were already introduced. We have a hotel booking website. We are actually #1 in Africa. But working for Africa is actually one of our biggest challenges. And our biggest challenge working there, I don't know if anyone has any idea what can be the biggest challenge when working in Africa. Any idea? No idea? Okay, you saw the presentation before. That didn't count as a correct answer, but that's right. I'm just going to change my, And yes, so basically our biggest challenge is internet, the speed of the internet. So, currently, no, it's not me, it's just a turtle. So, currently, most of the internet there, it's a 2G, and 75% of the users have a 2G connection. And worse, in 2020, there will still be 45% of the users working on a 2G connection. So, how do we build websites for people that have such a slow connection? For us, it's super fast. We open our apps inside the office, everything works super well, super fast, but then we get there and we have an issue, okay? So that's exactly what we did. So because of performance, we invested a lot of time and effort. I'm not going to speak about money, but that's usually what comes after time and effort, to try to improve our apps and website. So we went there and we asked the guys, so what do you guys think about our product, Is it fast enough? And the answer would be yes. But no. The answer was mobile site is way too slow. So we have an issue. But I say, but we have a super good app. We have an Android app. At this time, we had an Android app. Now we have both. And we said, okay, guys, so just download our app. It's super good. They say no, because it takes too much space. It's just 30 megabytes, but it's too much space for the phones that they use. So because of that, we wanted something that, now I'll just read the phrase, because it's a super good phrase. that is fast on slow connections without compromises on user experiences. This is exactly what we wanted. Okay, for that we started investigating a bit, and we came up with progressive web apps. You know, they promised a lot. So what they promised was, it should be fast, it should be reliable, and should be engaging. So we said, okay, let's give it a try. Then we spoke to Jose, and Jose will speak in just a moment. You know, and we asked him, no, can you try? Let's try to build a prototype or something. And for that, we use the app toolbox, and now Jose will.
Hi, Mike. Thanks.
So, just be in the background doing some breakdance or something.
As head of development, I'm in my corner developing, like most of you guys, and I get a product manager that comes to me and says, Jose, we need to be faster. We need to have something faster. I think that most of you will like with this, like, yeah, okay, we need to be faster. So we have the solution for you, which is nice. It's a product manager that has the solution for the tech team. We have the progressive web apps. And I'm like, okay, I will check on that. So I did what probably most of you guys do, is Google progressive web app. What is it? So yeah, all those promises are the main experience that the progressive web app meant to be. But also with the progressive web app, I read a little bit more, and it's supposed to give to the user an offline experience because he has the service worker. What is a service worker? And other goodies like push notifications and stuff like that. So I thought, yeah, why not? Why not trying it? Maybe the product manager this time is right. So checked a little bit more on this, and I found out about a nice library, Polymer. So I don't know if you guys know Polymer or ever heard about Polymer. Did you? Yeah? So I double-checked Polymer because they already have a web component for the service worker, which make my life pretty much easier. But then I read a little bit more about Polymer because I got a little bit more interested. So I put on the side the progressive web app for 1 minute, and I checked on Polymer. And with Polymer, at the time it was called Polymer Starter Kit. Currently it's the app toolbox. This is what we use. And I checked on the starter kit, and it was super cool. Why? Because I have already all the practices there, the good practices on the starter kit. It was for free. I had a set of tools, extraordinary tools to start building web components, to actually build the application at the end, and to have things that the progressive web app should be. The feeling of being in a native app and having an app shell. So I took a deep dive on the toolbox. I really love it. And I decided, yeah, why not? Let's build a prototype then. So I decided to do a prototype that should be something close to what we had at the time, our native Android application. So we built like in 4 weeks the main funnel, or half of the main funnel. Home screen, catalog page, hotel details, and home details page. It was really great to see, sorry. We did it, and we were really happy. We saw what we did, and it was a product that actually we could actually ship because it was consistent, it was working. So we decided to take some metrics to understand if it was worthwhile. So we saw it was twice faster in terms of page load than our current mobile website. It was 6 times less data consumption comparing to the native app to download, and it was 30% less data on the network comparing to our current mobile. And I talk about the fact that in Africa, connections are slower. But the reason why Africans don't want to download the application because it says it takes too much time, too much space, sorry, understand that the most common phone over there has a small amount of space in terms of storage, but also their data plan is very, very small. It's like 50 megabytes per month, and it will cost something like 20% of their wages. So they don't have that amount of money to spend actually on these kind of things. So the fact that we could reduce so much in comparison with the native app was so great. But for me, as a tech lead, I really need to understand the next bullet point. Is this technology so new that it's to stay, or something that will go away because it's just an hype, everything's cool, it's another framework? It's not a framework, it's a library, but it's another new things. Well, So I decided to talk with the guys that I think they know better about this. So I contacted the Chrome Dev tool, the Chrome Dev team. And the guys told me, give me some advices. And the best advice I think that I got was, hey, use the platform. And what it means to use the platform. The platform is pretty much the standards. And every day we work with the standards. We have the HTML, the web, all of these are standards. And some of them already exist like for 15 years. So it means that if you have a standard, it's meant to stay. So web components are now, from today, I don't know if you guys know, on their Abeno release, on their version 1. At the time we built this, we were using the V0 version of the web components. And looking at this, we decided to go a little bit backwards and to rethink about our mobile application. So we went to use JavaScript, pure JavaScript, take some advantage in terms of performance using the database storage that you have on your browser, like IndexedDB. And of course, we decided to change the way we were doing things to orient them on web component based using Polymer. With the combination of all of this, it was possible for us to remove a lot of frameworks that we have in JavaScript on our applications. Frameworks like those that I want to say the names, but format your website, make it responsive and stuff like that. For us, it was really important to understand the meaning of use the platform. I think if you search about these topics, you will see the hashtag a lot.
Okay, so everything is looking good. Everything looks great. It's a really nice picture. High definition, everything. But so we decided everything looks good. Let's go to production. But that's when our biggest challenges started again, because life is a big challenge. So we just noticed the biggest challenge were still ahead. People, we had to deal with people expectations, mostly top managers. We had product decisions to be made, product design. We already had a product, so this one needs to be better than the last one. We have technical issues that, it's a more or less recent framework, so it can bring us some issues. So we needed to manage change. We would say that by default, people are usually lazy. I'm lazy, he's super lazy, so, and people don't like change, just ask someone to change chair in the office, they will be super suspicious about it, So people don't like it. So we needed to make sure that we have our top management support on this. So we basically built a successful user, We added some metrics, and he got convinced. So we had a green light. Then we also need to train our developers because, new technology, we need to take time for developers to learn. We involved some of them on the prototype phase, and they learned something, and then they could also share some knowledge. So it was a good thing to do. Then came the product challenges. First one is app discovery. Let's go here. So we have the native app that we have it already. And the native app is on the store. On the store, you put the app inside the category. So it should be travel and local, I think. Then you have text, you have image, you have pictures, you have descriptions, you have a bit of everything. So people that go to the App Store, actually not App Store, sorry, the Play Store on this situation, they go there, they search for it, and they will find it because they are searching for something specific. They know what they are searching for, and they will find it. Okay? On the web app, there is no store. Okay? It's just a website at the end. So this is our current native app, current home screen. So we have here, you can, well, let me see where I can put those cool lights, okay? I always wanted to use this. So here you see, we don't...
This is why I brought them.
Yeah. So, here we have hotels, okay? Because we load, people know that they are using an app for hotel bookings, so we immediately load hotels on the home screen. Usually these are hotels around us for someone that wants to find a quick hotel, On the web app, not so quite. We need to tell people exactly what it is, how to find us. So, again, so we put, oh, no. Now you saw it all.
Oh, you're showing all, man.
Yeah,
Stop.
Let's go back, okay. So, here on top we put our brand, that is Jumia Travel. Here we put a catchphrase, one. Here we put some unique sentences, and then at the end we put the footer. The footer with about us, sorry, not footer, but it's important here, it's about us. Okay? So people have enough information to understand who we are and what the app does. Then comes the branding. On native apps, usually 100% of the users land on the home screen. I would say not all of them land, because we can use deep linking and send them directly to an hotel list or to wherever we want, or to an hotel detail. But as like normally, they will land on the home screen.
Stop. Do you know how many will land on the home screen on desktop? On your mobile phone, the web? Do you have an idea? Someone? So, 17, you think?
7-0 or okay?
7-0?
Okay,
Let's
okay.
see.
Okay, so let's see. Actually, next time we'll do that very cool things like I didn't know about it, but I will use it next time. So, no, actually only 20%. You know why? Because usually people land on a website based on a Google search. And when they search for, I want hotels in Lagos, or I want hotels in Nairobi, or whatever. It doesn't matter. So usually it will be directed to already an hotel list, or they search directly for an hotel name, and they will end up in the hotel directly. So it's very rare, you know, like only 20% of the users land on the home screen of the app. So again, this is the native app. Let me use this again. Okay, this is our native app. This is the hotel list. So this is basically after the home screen, we get to this page, and this shows a list of hotels, and then you can filter and sort and do whatever you guys want with this. Sorry, there is no branding anywhere. No catchphrase, no nothing. Why? Because people know what they are using, so there is no need for it. On the web app, we needed to build this top bar where we put the brand, and also we also use it then to change currencies and language and stuff like that. Here it is. And then, again, at the end, on the bottom, we have the About Us to explain. If people need to understand what they are using, who does it belong to, they go to About Us and they will understand. Now comes navigation part. So, on a native app, both Android and iOS, they have their own framework, they have their own, you know, how do you say, predefined ways to, you know, for a user to navigate the app. Here, we don't have that, you know, it's a new app. We needed to decide. So what we did, we use historical navigation. So because this is basically a browser, this is a browser, so everything on the website. So when you click back, you go back in history. So if you come from the home page to the hotel list, you click back, you go to the home page again. Okay, both top and bottom button. Oh, and if by any chance, I was going to forget this, if by any chance the user starts getting lost going up and down the hierarchy, they can always click the top logo, Geometravel, that will take them to the home page. So it's an anchor for the guys that get lost. They will click and they will find themselves in the home page again. So then we have basically two types of pages. The main pages, that are these ones, and we'll go to a bit more detail on them. And secondary pages that will also go on a bit detail after this. So the funnel pages, the main funnel pages. So this is basically home page, hotel list, hotel detail, checkout. What is the difference between this and the next one? So these ones respect website hierarchy. Again, you go up and down the hierarchy, you know, from top to bottom. We have the browser navigation history. If you press back, you go to the previous page that you were. We have a dedicated URL folder, because if you want to send someone directly, so you guys build up a campaign, you know, on Google, and you want to promote a specific hotel, you put the direct URL, so this is important to have. Okay, and it's branded for new users, because users, when they land on each one of these pages, but it's the pages that they can land, they need to have the brand that they are looking at. Secondary pages, not so important. Basically, for data input, we have a cross on the top, but there's no need to add browser history navigation, no need for branding, because again, no one will land directly on any of these pages. So, and if they click back, what we do, we close the window. There is no back, there is a closing the window, and we show the page that we were previously. Okay, now technical challenge.
So yeah, after building the prototype, the product management team investigate a little bit more about all these issues, because we want to have a native app-like experience on the web, and they found out about all these problems. And they came to me again and they say, well, this is the problem we want you to fix. So, okay, then. So we find all those solutions for those problems, like the secondary page. If you click on the back button, the physical back button, it will actually close the secondary page without changing the navigation. Of course, it's not true. This is what you see, it's not what happened, because it actually goes back on history. There's no way to go around this. But there was other technical challenges that we had to face. The first one, it was pretty much a new mindset. Like, look, you have teams of developers that are used to work on like classical web. You have a user doing a click, request to the server, gets a page, and it works pretty much like that. But since we decided to go with the web component approach, and we changed the architecture to something close to a single page application. I'm sure that all of you already know what is a single page application. It's super cool. You can do a lot of special effects and stuff like that. But since for us it's really, really important, the performance of that page, we kind of needed to make sure we were not giving to the user the full application in a single request. What I mean is like a user getting to the home screen, for instance, downloading all the application at once. So for that, we used the cool things that the app toolbox had to give us, like the service worker and the purple pattern. So I'm going to actually change trade places. I'm going to talk first about the purple pattern. Do someone knows what it means, purple, in this case? Someone been interested? You know it. Okay, so the purple, if I'm saying right, is push. The first P is for push, which is the purpose for you to serve to the user what it really needs to see what in the URL is requesting. Only that information. The R is to render. And on the concept of the rendering, it's really important to understand two things. The first paint, when the user starts to see something, and the first time to interact, when the user actually can start touching or messing around with your application, even though the application is not fully loaded. It's really, really important. Statistics will say that if the page takes more than 3 seconds to load, the user just will go away. So imagine 3 seconds in 2G. The other P, it's for prefetch, which is actually the trick. Since we only give to the user what it needs to see the page is requesting, on the background we use the service worker, and I already say service worker like 3 times without explaining it. You know what is a service worker? Not really?
I don't.
You don't?
Sure.
We will review that on your evaluation. The service worker is like a new, super awesome, cool feature that your browser has. It's like a man running in the background, maybe naked. And what it does actually, it's like a man in the middle. It's like a piece of JavaScript that you can put on your application. And each time you do a request to the network, it will intercept your request. I won't deep dive on this because or else we don't have enough time. But understand that with this power, you can have actually the flexibility to request to the network a file, fetch that file, save on the cache from your browser. Then if there is some kind of problem with the network, something like that, you can actually serve to the user what is in the cache. Or if the file hasn't changed on the network, it's the same file, you can reuse the cache instead of going to the server. And then the L means lazy loading. And this lazy loading is really also important. Even though you can serve all the content that the user is requesting to see on that page, you can create components that you will only fetch asynchronously. What I meant is, in the case of all the secondary pages that you guys saw, the only way to get to those pages is actually through an action. You need to click on a button. You need to click on something. So it's not something that the user, or maybe it's something that the user will never do. You don't know. So you don't need to preload this. You just wait. If the user actually click on that button, you will request to the server the content of that screen. So this is very flexible. It gives you a lot of potential to only download what is necessary, gain the most performance as possible, and to save a lot of data consumption for your customers. Another thing, it's like, and this is to give you an example how the web components are very powerful. The app toolbox brings you a lot of things really out of the box. And one of them is the routing system, which you can use to emulate like URLs on your application, even though you only have a single page. But we only did this prototype and this application for mobile. It's not for the desktop experience. You have like 2 applications. But all our SEO already exists already exists. And we wanted to keep all that knowledge in terms of SEO. So we really wanted to maintain all those URLs compatible. Thanks to the capabilities of the web components, it was possible for us to extend them because web components are nothing less than a piece of presentation, HTML, styling, but also JavaScript. And with this JavaScript, we could extend it and build our own routing system to maintain all the compatibility with the URLs. This was really important, guys.
Okay, so now this brings us to the latest challenge that we face. So finally, after all these challenges, we thought, okay, we should have everything ready, or we are almost ready, but not yet. We had a last effort because when we measured the loading time, okay, so this is
First
not
request.
yet. I know. So the second screen will show you the actually loading time of our old web facing the PWA on a 2G connection. Okay. So you guys can see.
Okay. You have the first print really fast. It's already gone.
Yeah. So this is our problem. Actually, the old web is a lot faster than PWA because it's a single page application. We load everything on first request. Okay. At least first time the user gets it, then he gets cache and stuff. So yeah, whatever. But he will explain a lot more in detail. So because of this, we have an issue. So we need to find a solution because again, if we're making this to improve performance, what's the point of going live with this? If actually the first time the user gets there, it's slower. There is no point on doing it. So we needed to find a solution, and the solution was AMP. Now Jose will speak about it.
So yeah, imagine my face when I show to the management, hey, we did it, look at the first impression, it's slower. It took 9 months. Imagine the cost, and it's slower. Of course, this was an example on 2G, and for the first impression, what it means is that as soon as you click on any other fragments, you go to another page, yes, the Progressive Web App will kick ass the other one, the old one. In terms of data, in terms of speed, because you already fetch the application. It's on the background thanks to the service worker. But the first impression really counts, and seeing the user waiting that much for the page is not really cool. So once again, talk to the Google guys. Hey, oh my God, you told me to use Progressive Web Apps. It's that worse. And the guys answered to me, what? Use AMP. Once again, I was in this place, or what the hell is AMP? Okay, Google again. And AMP means Accelerated Mobile Pages. And AMP, it's a project from Google that was mainly focused in the beginning for publishers, like news, like you can see the best example is the Washington Post. And the purpose of AMP, it's for you guys to build an AMP version of any page of your website without using JavaScript. So it's a very basic version of the website with the HTML, CSS, and telling Google, oh, you can cache this because it's AMP compatible. And Google will get that page, will cache on their servers, and will put a service worker running on those pages on your phone. It means that each time you search something on Google, the result, if it's AMP compatible, Google will serve the AMP version of that page. It will take more or less 1 second to serve, even on 2G. So it's super fast. So we decided, oh yes, thank God you saved my life. But even though I was thinking, okay, I will put those pages on AMP, but then what? The first impression is cool because AMP is fast, but the second impression will be better because any links on the AMP, since we cannot use JavaScript or super mega features, you need to link everything from that AMP page to your current mobile website. And then start looking at the catalog. And AMP has many web components built on their side. They have a full library. And one of them catch my eye. It was the AMP install service worker. So with the AMP install service worker, you can actually put on inside your AMP page like an iframe that will request your service worker to start. So the trick is, bottom line, the user will search on, the user will search on Google. Of course, AMP is only for mobile. That's the AMP. The user will search on their phone for results like hotels in Lagos. He will get an AMP result. He will open that page. As soon as the page is loaded, it will request the service worker in the background to start working for the Progressive Web App. The user will start reading about this page. Any click he will do on this page, it will be redirected to the Progressive App with the app already loaded because it's been loaded on the background. So it's a combination of multiple technologies from Google, since Polymer, the PWA, the AMP, all together, and also with Go, but we're not talking about Go. It's also something we have on this project. that make us be able to look to a brighter future. And we really think now that we are almost ready to go in production. Actually, we already have this application on preview environments. It's publicly available for everybody. And we can see that on the last results that we can actually serve such an application in 2G fast, below 6 seconds, I think. Guys, I really want to thank you. I don't know if you have any questions at all about any of those 1,000 topics. Only one. Okay.
Probably goes beyond the scope of this talk, but I was wondering, you said that they have like limit data, like 50 megabytes per month or something like that. So they download images. How do you do that? I don't know. How do you restrict the number of images they download? Because it takes a lot of data, I guess.
Yeah, for sure. I'm not totally sure about this. I have some numbers. I can tell you that the most common way for those guys, and the studies that I have is in Africa, but also in India, is that they have one phone, two cards. One card is usually used for phone calls and the other one for the data connection. And even when they decide to go offline because they don't want to accidentally download data, they will put their phone on airplane mode. So about the pictures, I don't know if they have some kind of filters or feature. I really don't know. But those are real numbers, and this is the reality over there.
So basically in terms of pictures, what we try to make our pictures on the website as small as we can. You know, so we always ask the content team to try to upload them super small, and we are always looking at, because sometimes we found a picture on the website that is like 1 megabyte bigger and said, forget it, take it off, put something smaller. But all the rest, yeah, you know, it's not easy for Africa. It's a hard market. So any more questions?
No?
No?
Thank you.
Thanks. Bye-bye.
Just a few information. We're gonna do a coffee break now. Afterwards, we're gonna have our last talk.